let's now look at this worksheet that we have right here. This worksheet contains questions from the topic numerical differentiation. So there are a total of 4 questions here, okay, and we'll start from question 1 and we'll continue in that order. Okay, so we're going to answer each and every one of them, but of course not all of them within this video. So just make sure to say you are subscribed to the channel and ring the notification bell so that each time I upload uh, um, any video or videos of this kind, you're going to receive a notification. Okay, so let's get into this. Question 1, we are given a table of values. Okay, and question 1a is asking us to use all appropriate formulas to approximate f prime of 0.4 as well as f prime prime of 0.4. Then B, we also have to use all appropriate formulas to approximate f prime of 0.6 as well as f prime prime of 0.6. Okay, so let's see how this works out. Um, so for the data that is given, let's see if we can determine our value of h. Okay, so the way we get our value of h is that's the difference between these two values, or these two values, and that one, like that. So just more like you have to do the subtraction there. Okay, so if we say 0.4, if we say our h is simply equals to 0.4 minus 0.2. Okay, so this is the same as if you said something like 0.6 minus 0.4, or you said 0.8 minus 0.6, or you said 1.0 minus 0.8, which is actually going to give you 0.2. So it simply means our step size, which is h, is simply h is equals to 0.2. That's what we are going to use. So on part A, okay, part A, we are trying to approximate f prime of 0.4 as well as f prime prime of 0.4. So let's start with f prime of 0.4. What are we going to do? So for this one, I'm going to first of all apply the central difference formula. Okay, so this is just more like the 3-point midpoint formula, which is given as f prime of x naught is equals to 1 over 2h. Okay, open bracket, you have your f of x naught plus h minus f of x naught minus h. Okay, you have the error part here. Is it a plus? I'll leave it out for now, okay, because we can easily find it by subtracting whatever that we are going to get here from the exact value. Okay, so what are we going to do here? We know what our value of h is, so this is just going to be more like you are going to say we are going to do some substitutions, so that would be like 1 over 2 times our h is 0.2, like this. Okay, then for this part here, f of x naught plus h, our x naught is this one that you are trying to approximate. Okay, that's always the case. So here this is just going to be x naught plus h, which is going to be 0.6. Why am I getting the 0.6? Is 0.4 plus h, our h is 0.2, we get 0.6, minus f of 0.4, which is what we are trying to approximate, minus your h, you're just still going to get 0.2, like this. Okay, so what do we have here? Okay, so for this one, it's like this is of course f prime of 0.4. So this is 1 divided by 0.4. Okay, so what is our f of 0.6? Our f of 0.6 has already been given in the question or in the table, as well as f of 0.2. If you look at this, on these data points that we have 0.6 as well as what? 0.2. Then the values that we are trying to substitute are these values here, more like the output. Okay, your input is 0.6, then your output is what you have right here, and that's what you're supposed to substitute, and that's what you're going to do even on this part here. So where we have f of 0.6, from the table we have 0.808 0348 minus, where you have f of 0.2 in the table, you have 0.979 8652, something like this. Okay, so after you do the math there, you can just punch that on your calculator. You're going to end up with 0.429 576, something like this. That's what we get. So by using the central difference formula, okay, by using the central difference formula, this is what we have ended up with. Okay, that's what we have ended up with. Okay, so I'll not really bother myself trying to think about, is this value accurate or not, because I've not been given the actual function itself. Okay, like I've not been given the function itself, so I'm unable to find the exact value. Here it was just a matter of us doing the approximation. Then we can't really compare because we have not been given the we have not really been given the function, the function that we are, where we can find the exact value. So I'm just going to leave that one as it is. Okay, so what other formula am I able to use? So here the 3 point endpoint formula is also able to work. And how do we illustrate that formula? So everything else remains the same. So for this one here, the 3 point endpoint formula, you're going to have your f prime of x naught is simply 1 over 2h. Okay, 1 over 2h, and you have minus 3 f of x naught. Then here this will be plus 4 f of x naught plus h minus f of x naught plus 2h, there, like that. You also have the error part here. You also have the error part, so I'm going to leave that one out. So what we do here is still the same thing that we did in the previous one. So you're just going to have your f prime of 0.4 is equals to, so you're going to have 1 over 2 open bracket, your h is still 0.2 as we already have it, so it will be minus 3 f of 0.4, that's our x naught. Okay, that will be plus 4 f of 0.6. I'm just getting this from the fact that I know that my x naught is 0.4, my h is 0.2. When you add them, you get 0.6. Then I'll say minus f of, so here if you say 0.4 here plus 2 multiplied by 0.2, this would be like 0.4 plus 0.4, which is 0.8. So we have 0.8 right here. Okay, this seems to be very interesting. So down here, this is going to be 1 over 0.4. Okay, so it will be minus 3. So where you have f of 0.4, just go back to your table where you have your 0.4 here, get this value and substitute. Where you have 0.6, get this value. Where you have 0.8, get that value and substitute, and punch everything on your calculator. Okay, so here that would be open bracket, our f of 0.4 is simply equals to 0.91 77710 plus f plus 4 multiplied by 0.8. I'm getting all this from the table. So you have 0.3 here. So not 0.3, I mean 0.3. Then you have 4.8 close minus 0.6386093, and the answer that you end up with is minus 0.399458, something like that. Okay, that's the value that we get, and that is when we apply the 3-point endpoint formulas. So I know we still have some formulas such as the 5-point midpoint, as well as the 5-point endpoint formulas, but those, they are not going to apply in this case, and the reason why they are not going to apply is because you have limited limited data. So let me see if I can show you why we are unable to apply them. So that is for I'll leave this one. I'm still using it. No, I think we are done using it, but our h remains the same. So if you want to consider the 5-point midpoint formula, okay, it's given as f prime of x naught is equals to, you have 1 over 12h, then is open bracket, you have f of x naught minus 2h minus 8 f of x naught minus h plus 8 f of x naught plus h minus f of x naught plus 2h. Okay, so first of all, if I look at this part here, okay, I know to say this part is able to work, this part is able to work, this part is able to work, and here is what I mean when I say it's able to work. If you look at this, your x naught is 0.4. That's what you're trying to approximate. Your h is equals to 0.2. So if you say f of 0.4 minus 2 open bracket 0.2, what are we going to end up with? This is f of 0.4 minus 0.4. What does this give us? This gives us f of 0. If we come to the data set, we don't have f of 0. The lowest we have is 0.2. We don't have 0. So it simply means we are unable to use the 5-point midpoint formula. The same applies to the 5-point endpoint formula. If you write it down, try to test on those values. You're going to observe that you're going to have some f that is not within the data set, because there's actually a part in the, I'm not going to write it down. I'm not going to write it down. There is a part in the 5-point endpoint formula where you have something like 3 f of x naught plus 4h, like this. So if your x naught is 0.4, you say plus 4 multiplied by 0.2, what are you going to get? This is 0.4 plus, this is going to be 0.8. 0.4 plus 0.8 is 1.2, meaning you are looking for f of 1.2, which is actually not within the data set that we have, so we can't use that formula as well. Okay, so that's one of the reasons why I haven't used those formulas, because the question was just openly saying I have to use all appropriate formulas. So the others we can say they are inappropriate for now, at least. Okay, so let me go ahead and come up with the second derivative. So what I've done is just worked out this part here. Now let me work out this one here, which is the f prime prime. All I've done is just the f prime. So my f prime prime of 0.4, how is this going to be? Okay, so what will happen here is what we are going to use is a formula that is called the second derivative central difference formula. It's just more like the midpoint formula for the second derivative, and it's given as follows. Okay, it's given as f prime prime of x naught is equals to 1 over h squared, open bracket, you have your f of x naught minus h minus 2 f of x naught, okay, plus f of x naught plus h, like that. Okay, that's a plus. So this is there's an error part here, by the way, but I'm not just including it because I'm just more interested in using this part to approximate the value. Okay, so what will happen here is that it's a similar thing that we were doing in the previous one when it comes to the first derivative. So all we have to do is to say, okay, our f prime prime of our x naught. What is our x naught? Our x naught is 0.4. Okay, is equals to 1 over our h is 0.2, so just 0.2 squared, then you put the brackets there. So this is just going to be f of, on this part, what do we do? It's 0.4 minus 0.2 is simply 0.2. Okay, so it's f of 0.2. But again, remember to say your f of 0.2 has already been given in the data, which is this one here, 0.9798652. Okay, so it's the one that I'm going to write here. Don't have to waste my time writing this again. So it will just be 0.9798652 minus 2 open bracket. So f of x naught is 0.4. So just come pick this value here, which is for 0.4, and substitute it there. So here that value is actually 0.7, no, 0.9177710, is it? Yeah, plus for this part as well is 0.4 plus 0. Which is 0.6. So you're looking for f of 0.6 from the table which is given. Okay, so this will be 0.8080348. Okay, so what does this end up to be? So when you do the final answer, this is just going to be minus 1.19105, and that's the approximation. That's the approximation of the second derivative of 0.4. Okay, what else is remaining? So it's like we have done the first one, which is this one. So in a similar manner, try to work out 0.6, as well as, try to work out f prime of 0.6 as well as f prime prime of 0.6. Then uh, um, see the solutions that you're going to get, and yeah, but everything else is basically the same as I did on the first one. So that's all in this video. Thank you very much for watching, and we'll catch you in the next one.